Next, to find the value of A1 and A2, we consider equation number 12 at t is equal to 0. This is equation number 12. And from this equation, I can write the value of CB cross like this. So I have find out the value of CB0 in this form. So this is equation number 19. Now differentiate equation number 14 with respect to time. So this is equation number 14 with respect to time. So if I differentiate, this is a product rule. So first, differentiation of first and second, and differentiation of second and this one. So this is a simple differentiation. And now putting the value of t is equal to 0, then this equation like this one. After some simplification, this equation becomes this, because here is a1 and a2, then we can take a1 common from this equation and a2, so we have this equation. And now putting this value in equation number 19. So this is CA dot of 0 and here CA dot of 0. Putting this value here, then this equation becomes CB of 0 like this. And after some steps, I can find out CB of 0 this. Now look this equation number 16. If here is A2, so this is CB of 0 in this form, and if we consider equation number 16, and if I find the value of A1 from equation number 16, so A1 will be equal to CA of 0 minus A2. Putting the value of A1 in this equation, then this equation becomes omega plus delta divided by omega r, and the value of this is CA of 0 minus A2 plus delta minus omega divided by omega r and A2 and e to the power iota phi. Further, CB of 0, multiply this with this, omega plus delta divided by omega r into CA of 0 minus omega plus delta divided by omega r, A2 plus delta minus omega divided by omega r, A2 and e to the power iota phi. So A2 and A2, then we can take common CB of 0, which is equal to omega plus delta divided by omega r, CA of 0, and here if we take common A2 from this, then and take an LCM omega r, then this becomes omega plus delta, and I take also common from here, then this common, then this becomes minus, and delta minus omega and A2 e to the power iota phi, and CB0 omega plus delta divided by omega r, CA of 0 minus omega plus delta delta minus minus plus omega divided by omega r a2 and e to the power iota phi. This delta can be cancelled out and CB of 0, which is equal to omega plus delta omega r CA of 0 minus 2 omega divided by omega r and a2 and e to the power iota phi. From this equation, we can find out a2, and this is very easy because this term will come here, omega r will come here, and then we have omega r CB of 0 e to the power minus iota phi, which is equal to omega plus delta divided by omega r and CA of 0 minus 2 omega a2. Then this term, if we take this term in the left hand side and this term in the right hand side, then 2 omega a2, which is equal to omega plus delta divided by omega r CA of 0 minus omega r CB of 0 e to the power minus iota phi. And further a2 will be equal to 1 over 2 omega and omega plus delta divided by omega r CA of 0 minus omega r CB of 0 and e to the power minus iota phi. So this is the value of a2. And to find the value of a1, we must put the value of a2 in equation number 16, and from this we can find the value of a1. So we know as equation number 16, if a1, which is equal to CA of 0 minus a2, then putting the value of a2 here, and then minus a2 1 over 2 omega plus delta divided by omega r CA of 0 minus omega r CB of 0 e to the power minus iota phi. We must take CA of 0 and CA of 0 common from these two equations, and after some steps I can find 2 omega and omega minus delta CA of 0 plus omega r e to the power minus iota phi CB of 0. So this is the value of a1. Now we have the value of a1, a2, b1 and b2, and then we must use equation number 14 and 15 and putting the value of a1, a2 in equation number 14, b1, b2 in equation number 15. Putting the values of a1 and a2 in equation 14, then CA of t, which is equal to the value of a1 is 1 over 2 omega omega minus delta Ca of 0 plus omega r e to the power minus iota phi Cb of 0 and e to the power iota omega t divided by 2 and plus the value of a2 as 1 over 2 omega plus delta Ca of 0 minus omega r e to the power minus iota phi Cb of 0 and e to the power minus iota omega t divided by 2, and also we have e to the power iota delta t divided by 2. Further, Ca of t, which is equal to 1 over 2 omega, I can take the value of exponential form and sine and cosine theta, just like this will be equal to cosine omega t divided by 2 plus iota sine omega t divided by 2. So after this, we can multiply this with this and this. So this will be equal to omega minus delta divided by 2 omega and Ca of 0. If I multiply this, then omega r divided by 2 omega e to the power minus iota phi Cb of 0, and we have cosine omega t divided by 2 plus iota sine omega t divided by 2, this term, and similarly plus this omega plus delta divided by 2 omega and Ca of 0 and this minus omega r divided by 2 omega e to the power minus iota phi Cb of 0, and also this term cosine of omega t divided by 2 minus iota sine omega t divided by 2. So and here in multiplication we have iota e to the power iota delta t divided by 2. Iota e to the power iota delta t divided by 2. Now we have some multiplication here, and after some mathematical steps I can reach to the point where this is very simple, because this is a simple multiplication. Multiply this with this term, this with this term, this with this term, this with this, and similarly this is a simple multiplication, and after some steps I can take some common, and then we have omega minus delta divided by 2 omega and Ca of 0 plus omega r divided by 2 omega e to the power minus iota phi Cb of 0 plus omega plus delta divided by 2 omega Ca of 0 and minus omega r divided by 2 omega e to the power minus iota phi Cb of 0, and here we can take cosine omega t divided by 2 common. So from these terms, I can take cosine theta. And similarly, I can take common sine theta. Then we have the plus omega minus delta divided by 2 omega, and Ca of 0 plus omega r divided by 2 omega e to the power minus iota phi Cb of 0 plus omega r divided by 2 omega and e to the power minus iota phi Cb of 0 minus omega plus delta divided by 2 omega and Ca of 0, and here we have a common sine of iota sine omega t divided by 2, and also we have e to the power iota delta t divided by 2. Here omega r divided by 2 omega, this is positive, and minus e to the power minus iota phi Cb. This term and this term, this is plus, this is minus. So plus minus can be cancelled out. This term can be cancelled out. And okay, Ca of t, which is equal to omega minus delta divided by omega r and Ca of 0. This term, this is cancel out. And also if I multiply cosine theta, cosine omega t divided by 2, and the other term is plus omega plus delta divided by 2 omega Ca of 0, and with multiplication cosine of omega t divided by 2. And next we have this term, multiply this with this, then plus iota omega minus delta divided by 2 omega, this term Ca of 0 and sine omega t divided by 2. Just I have multiplied this and plus iota omega r divided by these two terms. These are exactly similar. Then we can add these two terms. These two terms can be added, and 2 omega r divided by 2 omega and 2 will be cancelled out. Then we have only omega r divided by omega and e to the power minus iota phi, also iota, because this sine theta is some iota, e to the power and Cb of 0 and sine omega t divided by 2. So these two terms can be added and we have this term, and minus iota omega plus delta divided by 2 omega and Ca of 0 and sine omega t divided by 2 and e to the power iota delta t divided by 2. Further, this term and this term, we have a common Ca of 0 and cosine omega t of 0. Then let's see what we can get from this if we take common this thing, this, and then we have omega minus delta divided by omega r plus omega plus delta divided by 2 omega, and we have a common CA of 0 and cosine of omega t divided by 2. And also we have CA of 0 here and CA of 0 here, and sine omega t and iota. So this term, if I take common iota, CA of 0 sine omega t divided by 2, and then we have omega minus delta divided by 2 omega, and minus omega plus delta divided by 2 omega. In one term we have iota omega r divided by omega e to the power minus iota phi cb of 0 and sine omega t divided by 2, and also with multiplication e to the power iota delta t divided by 2. Take LCM. Here one thing is missing here. This is not omega r, but this is 2 omega. This is 2 omega, sorry, this is 2 omega. And also here this is also 2 omega, 2 omega. So here, yes, this is 2 omega, 2 omega and 2 omega, yes. Now take the LCM. 2 omega is the LCM, then omega minus delta plus omega plus delta and CA of 0 cosine of omega t divided by 2 plus, take LCM here, omega minus delta minus omega minus delta, because this sign will act, and CA of 0 sine omega t divided by 2 plus iota omega r divided by omega e to the power minus iota phi cb of 0 sine omega t divided by 2 and e to the power iota delta t divided by 2. Here this delta and this delta can be cancelled out, and similarly this omega and this omega can be cancelled out, and we have the final equation as. So the final equation of CA of t will be equal to CA of 0, this thing, and because we have CA here and CA here, and also we have 2 omega here and 2 omega here, so this will be cancelled out. We can get 1, and also CA and CA from here, then we can have cosine of omega t divided by 2 and plus minus here minus 2 delta, and 2 will be cancelled with this, then we have minus iota delta divided by omega and sine of omega t divided by 2, and CA of 0 can be taken as a common here. Then the last term is plus iota omega r divided by omega e to the power minus iota phi and CB of 0 and sine omega t divided by 2 and e to the power iota delta t divided by 2. So this is, let's see, this is equation number A. Similarly, putting the value of b1, b2 in equation number 15, and then you can get directly, I can write this directly, putting the values of b1 and b2 in equation 15, then C B of t will be equal to cosine omega t divided by 2 plus iota delta divided by omega sine omega t divided by 2, and here you can take common C B of 0 and plus iota omega r divided by omega e to the power iota phi Ca of 0 sine omega t divided by 2 and e to the power minus iota delta t divided by 2. This is e to the power minus iota delta t divided by 2. And this is equation number B. So we have find out the goal of our this system is we have started this atom field interaction with a single mode, and our goal was to find out the value of Ca and Cb, and finally we found Ca of t, which has the expression like this, and Cb of t, which has the expression like this. And now this probability amplitudes have the information about this system. How? Let's see. Physical analysis. Initially, we consider that the atom is initially in the excited state. The atom is initially in the excited state means that the electron is here in state A. So this is the condition. If the electron in state A, it means that initially Ca of 0, which is equal to 1, because the probability, the maximum probability is in state A. So this is the maximum probability, and Cb of 0, which is equal to 0, because we have defined that the atom is initially in the excited state. So the maximum probability will be equal to 1 in the excited state. Further, we also suppose that the field frequency and the transition frequency omega AB becomes balance each other, and we have some resonance condition. It means that omega AB minus nu, which is equal to 0, and we can call this detuning. So detuning, which is equal to 0. Putting these two conditions in equation A and equation B, what we can get? Initially, this Ca of t, which is equal to Ca of 0 is equal to 1. So this is equal to 1. And here detuning is equal to 0. So this term will be cancelled out. And we can get only cosine of omega t divided by 2 from this. And here Cb is equal to 0, then this whole term can be cancelled out. And delta is equal to 0, it means that this is equal to 1. So Ca of t, which is equal to cosine omega t divided by 2. And further, We have supposed last time that omega r square delta square, which is equal to under root, which is equal to omega. This was the supposition. And if detuning is equal to 0, then this is equal to 0. And from here, we have omega r, which is equal to omega. So here, cosine of omega r t divided by 2. So CA cross of t, which is equal to this thing. And what about CB? CB of t. This term will be equal to 0 because CB of 0 is equal to 0. This will be cancelled out. And here, this is equal to 1. And let's see, iota omega r divided by omega, which is equal to omega r, and e की power iota phi, and this is equal to 1, and sine of omega t divided by 2, where omega is equal to omega r, so omega r t divided by 2, and this exponential term will be equal to 1. So we have two values, CB and CA. Now the probability. What will be the probability? The probability of this and the probability of this. How we can take the probability? The probability means CA of t absolute square, and this is equal to CA of t and CA of t star. So this is an even function, so we can get cosine square omega t divided by 2. And from here, CB of t absolute square and CB of t and CB of t star. It should be noted that if we put the value of iota omega r divided by omega r, so omega r will be cancelled out. So this is omega r will be cancelled out here. This is iota e की power iota phi sine omega t divided by 2. And what about CB star? CB star means minus iota and e की power minus iota phi and sine omega t divided by 2. 1 minus from here, and iota square. Iota square has a value of minus 1, and 1 minus is this, and so this is plus 1. E की power iota phi, e की power minus iota phi, this will be cancelled out. And finally, we have sine omega square omega, this is omega r, this is omega rt divided by 2, and this is also omega r. Now the total probability will be equal to CA of t absolute square plus CB of t absolute square, which is equal to cosine square omega t divided by 2 plus sine square omega rt divided by 2, and this is equal to 1. So it means that the total probability of this system will be equal to 1, and it is a reasonable point. If you plot under the condition of detuning is equal to 0 and CA of 0 is equal to 1 and CB of 0 is equal to 0, then you can take a plot of CA of 0 absolute square and CB of 0 absolute square. It means that the probability initially we have the probability of A state will be equal to cosine square omega RT divided by 2, and probability of B state is equal to sine square omega RT divided by 2. At t is equal to 0, we have maximum probability in the excited state. This is the excited state. The atom, the electron will be found in state A. So there is a maximum probability 1 in the at time t is equal to 0. And after some time, the probability decreases of the state A because the electron come back to state B after some time. So it means at that time, at time t is equal to 0, the probability of this electron in state B is equal to 0, and after some time the probability increases and it reaches to 1 when the probability at state A is equal to 0. And further, some time the probability increases of state A and the probability of state B is decreasing. And this process is continuous. This and this. So this is actually the probability of A and this is the probability of B. So it means that this electron have some oscillation in this two level atom, and omega r, which is equal to PAB absolute and E naught divided by H cut. It means that omega r is directly proportional to E naught. This is the field strength. E naught is the field strength. So if the strength is large, then the oscillation will be high and vice versa. What is population inversion? Population inversion means if we have a system and there are many number of atoms, and these atoms, when maximum number of atoms are in the excited state, then we can get the population inversion. It means that the population, the probability of state A, if this is a system with excited state A and ground state B, then the probability of state A is greater than the probability of particles atom in the state B. So the population inversion can be, if I represent this as on W, then the population inversion must be equal to PAT minus PBT. And PAT, we know CAT absolute square minus CBT absolute square. And we know about this cosine square omega RT divided by 2 minus sine square omega RT divided by 2. If we put the value of cosine square omega RT in this form, this will be equal to 1 over 2, 1 plus cosine omega RT and minus 1 over 2 1 minus cosine omega rt. So this is the formula cosine omega rt divided by 2 we can take like this and sine this. And after some steps, after one step, I think 1 over 2 can be cancelled out, and minus minus plus, and then I can get cosine omega rt. This will be the population inversion when detuning is equal to 0. If detuning is not equal to 0, then what will be the population inversion W of t? This is very simple. We can consider equation A and equation B like this. If detuning is not equal to 0 and CA of 0 is equal to 1 and CB is equal to 0, then CA of t will be equal to cosine omega r t divided by 2 minus iota delta divided by omega and sine omega t divided by 2 and e to the power iota delta t divided by 2. This is probability amplitude of A and probability amplitude of B, iota omega r divided by omega e to the power iota phi sine of omega t divided by 2 and e to the power minus iota delta t divided by 2. So what will be the population probability amplitude PA of t, which is equal to CA of t star and CA of t. So CA of star, this one, if I take the star, then cosine of omega t divided by 2 plus iota delta divided by omega sine of omega t divided by 2 and e to the power minus iota delta t divided by 2. This is the star. And CA of t, this one, with multiplication, this one cosine of omega t divided by 2 minus iota delta divided by omega sine omega t divided by 2 and e to the power iota delta t divided by 2. If we multiply this with this, so this term will be cancel out. And finally, if after some steps, finally probability of A will be equal to cosine square omega t divided by 2 plus delta square divided by omega square and sine square omega t divided by 2. So this is the probability of state A. And similarly, the probability of state B. This is the probability of state A. The probability of state B will be equal to CB star and CB T, and this is equal to minus iota omega r divided by omega e to the power minus iota phi sine omega t divided by 2 e to the power iota delta t divided by 2, with the multiplication of iota omega r divided by omega e to the power iota phi sine omega t divided by 2 e to the power minus iota delta t divided by 2. If we multiply these terms, then the probability of t, this and this will be cancelled out, this and this will be cancelled out after multiplication, and finally we can get omega r square divided by omega square sine square omega t divided by 2. So this is the probability at state B. And what will be the population inversion? The population inversion is W of t, which is equal to probability of A minus probability of B. So this is this one, cosine square omega t divided by 2 plus delta square omega square and sine square omega t divided by 2 minus omega r square divided by omega square and sine square omega t divided by 2. So this is the population inversion, and we can also take a common, maybe from here and here we can take sine square omega t common, and finally this omega t, this omega, you can say this omega or w, this is just a representation for the population inversion. So if you call this w of t is okay, then cosine omega t divided by 2, and you can take common from here, then you have delta square divided by omega square minus omega r square divided by omega square and sine square omega t divided by 2.